Hi everyone, thanks for watching my YouTube videos. I'm Sang Kim. In this video, I'm going to show you how to calculate the standard errors of exponential survival analysis. In the previous video, I showed you how to do exponential survival analysis in R by using subreg function or AFT-reg function or flexor-reg function. And also I showed you how to estimate these coefficients based on this log likelihood function, right? There's one reference book for this video. Hosmer, Lemeshow, May actually published a very good book to understand survival analysis. And according to this book, log likelihood function can be calculated by sum of event times log of PDF plus 1 minus event times log of survival function. And it can be simplified like this form. And as you know, in order to calculate the standard error, we need to calculate second partial derivative of the log likelihood function. And it can be defined like this format. So in this video, let me show you how to get these standard errors in Excel. Again, let me use this simplified log likelihood function formula. And let's use this second partial derivative form to calculate standard error. Yt is equal to log of fu time and z, this one, yt minus, sorry, let's set initial value for b0, b1, b2, log of average of fu time around 6, so let's say 6 and 0 and 0 for initial as an initial value. Then z can be calculated by yt minus b0 minus b1 times rx minus b2 coefficients times age. Then log likelihood, this formula, event times g minus exponential of z value. So we want to maximize the sum of this log likelihood. Okay, and let's use solver, this one. Set objective, sum of log likelihood, and we want to change value from these cells. Unclick, uncheck this box, and click solve. Right. Then let's click again solver till it's not changing, because I think Excel solver is a little bit sensitive about this optimization. Okay, it's changing. Let's click solver again. Okay, it doesn't change anymore. So as you can see, this is very similar to this R output, right? So we can use this formula to calculate to get estimated coefficients, this one. And let's move on how to calculate standard errors. So this part can be calculated by matrix form. So if row, let's fix row and column. So if row and column is same, then let's get exponential of z value. If not, let's give value as 0. Control C and Control V. Okay. I actually used a conditional format to check whether only diagonal elements are over value 1, right? Then again this formula. Let's get information matrix. So mert transpose of independent variable including intercept term, this one. And then exponential of zi and emerge times independent variables, and press Ctrl Shift Enter, right? Then we need to calculate the inverse of this matrix, because this is information matrix, and inverse of information matrix, press Ctrl Shift Enter. Okay, then standard error for V0 can be calculated by square root of first diagonal element and square root of second diagonal element and square root of third diagonal element. Then it is the same as R output, right? Then Z can be calculated by coefficient over standard error. Okay, and then p-value is actually 2 times 1 minus normal distribution of z value, comma, mean as 0 and standard deviation as 1. Not true, because cumulative. Sorry, we need to add one more parenthesis and Ctrl C. So let's use absolute value of ABS of z value. Then Ctrl C and Ctrl V. Then it's same as our output. So as you can see, under 5% significance level, age variable is significant. However, Rx variable is not significant under 5% significance level. So again, this book, Hosmer, Lemeshow, May, actually provided very good background of log likelihood and standard error for exponential survival analysis in parametric survival analysis chapter. I hope this video was useful to understand how to calculate standard errors for exponential survival analysis. Please click like and subscribe if it was useful for you. Thank you.